guys, welcome to another video. My name is Roland and I'm your tutor. In this particular video, we'll be discussing prime factors of the powers of 10. It's quite interesting the relationship that one can see when you use powers of 10. So let's get straight on into it. If we decompose the powers of 10 into prime factors, we start to notice a bit of a pattern. Can you guess what the pattern is? If you can't, stay tuned and you'll see what it is. So, when you have 10 to the power of 0, you have the answer 1, don't you? Now, if you have 10 to the power of 1, you've got 1 naught, because it's 10. If you've got 10 squared, you've got 2 noughts, because it's 100. And so it goes on. Let me show you how it all works. So if I say 10 to the 1, I'll see the answer is 10, which means a 1 with 1 extra naught. It's the same as saying 2 times 5, and you'll see something else that's coming up. When you have 10 squared, it's the same as saying 100, which is 1 with 2 noughts. 2 squared times 5 squared is actually 100. So whatever number is your power for 10, you'll have that same exponent on your 2 and 5. The pattern continues, and you see 10 to the power of n is 1 with n zeros, and 2 times 5 with the powers being n as the value. Look at 10 to the 4 for an instance. If you have 10 to the power of 4, you'll have 1 with 4 noughts, which will be equal to 2 to the power of 4 times by 5 to the power of 4. It's a nice little pattern to take note of, and it can actually help you quite a bit when solving questions. So I'm just making a quick note about this, nota bene on the top right there. So 10 to the nth power means that whatever power 10 gets, there will be that number of zeros on the 2 and on the 5 when you multiply them together. There we go. Quite an interesting little discovery we've just made, isn't it? Let's put that little bubble around there and do an example. This could easily be an end of paper, 5-mark, high-level question that most people won't actually realize. And it's actually quite simple, judging from what I've just shown you. So anyways, that's a cool trick. Let's do this example. So, what would we do with a question like this? Clearly 7 to the power of 100 is an insanely large number. I mean, 7 times 7 is already 49. I mean, I'd only take a guess at 49 times 7 being something like 50 times 7. That'd be like 350? No. Yeah, probably around that. Minus like 7. So probably around, what, 343? Does that make sense? What would you say? Yeah, it's about that. Anyways, that's not important. This number is far too large to calculate, even with a calculator. I mean, that's 7 cubed. So let's take a look. What are we given? We're given a composition of numbers, and we now need to take those numbers and put them into their prime factors. We see that we've got 2 times 5, and we can also see that there's more 5s than there are 2s. So let's rewrite the number so as to group terms correctly. Okay, you naturally want to be seeing the same number of 2s multiplied by the same number of 5s. Anything after that we'll deal with accordingly. So what are the numbers that we have? We've got 2 to the power of 3, 5 to the power of 4, and 7 to the power of 100. That's literally the same as saying 2 to the power of 3 times 5 to the power of 3 times 5 again times by 7 to 100. If we were asked to find what the last 3 numbers of this answer would be, we can clearly see that the answer would be 3 noughts. But anyways, I'll show you this. So we've got 2 to the 3 and 5 to the 3, okay? Times by 5 times by 7 to 100. This means that when you've got 2 to the power of 3 and 5 to the power of 3, we know that it's 10 to the power of 3 from what we learned earlier. This would mean it's 1,000. So whatever the answer in brackets is, we'd also have to multiply that by 1,000. Therefore, the end of the answer would have 3 noughts. Okay? Nice little trick to know. See, this is how it can really come in handy. So if you get any sort of random number and you see that, you can break it down into prime factors, and you can see that you've got a 2 and a 5 in its prime factors, you can then say, okay, well, I've got the same number of 2's and the same number of 5's, therefore I can determine the number of noughts at the end of the answer. So, as we saw over here, we've got 5 times 7 to 100, and we know that at the end we need to multiply by 1,000. Nice and easy. So, the result would be whatever 5 times 7 to 100 is, and then you'd multiply that by 1,000. Right. There we go. So we'd say 5 times 7 to 100 with 3 zeros at the end, which is quite simple if you think about it. Therefore, the last 3 letters, or 3 numbers, or 3 digits, whatever term you want to use, would be 0, 0, and 0. There we go. Easy game.